Welcome to a very special episode of the Coding Train with our guest today, Patt Vira. Pat has an incredible number, over 100 at least already in the last year, of tutorials and videos about P5.js, creative coding. So if you like the Coding Train, you're going to like Pat's channel.
I hope so.
So we're here today to do a special collaboration. Pat happens to be in New York for ITP Camp. ITP is the program where I teach during the year. They run a month-long program in June for camp. And I just so happened that yesterday I taught a quick workshop at ITP Camp on the ML5 library, which also just yesterday had a 1.0 release. So what we're going to do in this video is introduce to you the new release of the ML5 library, show you the new ML5 website. I'm going to give you a quick walkthrough of how to code some stuff in ML5, and then Pat's going to make it much more visually interesting and exciting. All right, so what is ml5.js? The ml5 project started in 2017 when researchers at Google were developing DeepLearn.js. And we asked the question, could DeepLearn.js, which was a library to run machine learning models in the browser, could we run those models with P5.js? DeepLearn.js later became TensorFlow.js, and the ML5 project has had many years of development with different models and tutorials and examples. But in the last year, a group of us at NYU in New York and at NYU Shanghai have been working on updating the library to use a bunch of refreshed new models for pose tracking, as well as some new functions for training a neural network, all of which I explore in a lot of detail in chapters 10 and 11 of my new Nature of Code book, which I think I've probably mentioned way too many times on this channel. So let's take a look at the ML5 website, and I can show you what some of the new features are. This is the new ml5.js website. I encourage you to take a look at the About page so you can learn all about all of the wonderful people who are contributing and building this library. The Getting Started page is probably where you want to begin, just to find a quick walkthrough of how to get started with the library and the P5.js editor. Under the reference, you will see here on the left all of the machine learning models that are currently supported in ML5. There is a model for tracking body pose, for hand, key points on your hand, key points on your face. That's what we're going to use for this tutorial today. There's an image classifier, a sound classifier, a sentiment analysis model, as well as a module for training your own neural network. So I think I'm going to go to the body pose page. Each model page includes a description, a demo. Let's run this demo here. I'm going to allow it to use the camera. So I'm going to just awkwardly stand up. So the body pose model, you can see, captures 17 key points on the body: eyes, nose, hands, shoulders, hips, knees, and toes. And this is actually, this particular model that it's running is called MoveNet. One of the wonderful things about on the website is you can run the demo here, but you can also click to just look at the example. And you can see the example code here in the P5 editor and start playing around with it yourself. More examples are linked below, as well as a step-by-step guide. And then all the way down on the page, there's more details about the specific properties and functions for more detailed documentation of everything you can do with the body pose model. I also just want to quickly highlight that the new ML5 has a body segmentation model in it that will give you a colored pixel map of every pixel and which part of your body it's associated with. In a minute, I'm going to show you how to import the new ML5 library and write code with it. But just in case you happen to be a current user of the previous versions of ML5, there's a lot of models and functions that you still would have to access by using version 12.2. Okay, so let's get started using ML5. I've got a completely blank P5.js sketch. Now, normally, if I'm working on a project that uses the ML5 library, I'm probably just going to click on one of the examples, which will already have the library imported. But I'm going to show you here step by step, if you're starting from a blank P5.js sketch, how to import the ML5 library. If I click on the Getting Started page and scroll down, there's some instructions of how to do it here. But this is what I'm looking for. I'm looking for this script tag to where the ML5 library is hosted, and you'll notice this at 1 because we're using version 1.0 of ML5. I'm going to copy this to the clipboard. I'm going to go back to the index.html file in the P5.js sketch. You can see how the P5.js libraries are being referenced here through script tags, and I can now just add by pasting in the ML5 library. One thing I'll note is that you want to make sure that you're using the most recent version of P5. I'm going to show you in a minute how some features in the newest P5 work really well with the ML5 library. The next thing I'm going to do, which is not related to ML5 specifically, is I'm going to open up a connection to the webcam on this laptop and see that in the P5.js canvas. I'm going to create a variable called video. In setup, I'm going to call create capture. And we can see here already, there I am, hi. That is the DOM element floating on the page separate from the canvas. Now I could leave it there, but what I want to do eventually is draw over top of the video. So in order to do that, what I'm going to do is actually call video.hide so you don't see it anymore. I'm going to change the size of the canvas to 640 by 480, which is the size of the video, and then draw the video on the canvas with the image function. I'm going to show you something that's in the new version of P5 that is incredibly exciting to me. Now, I'm holding up my hand. This is my right hand, but it's showing on the left side of the canvas because it is not mirrored. And if you've ever watched any of my other videos where I try to mirror the video, I've got to look up translate and scale and use the negative number and all sorts of stuff. But the new P5, I can actually add an option to the create capture function with a property called flipped and set it to true. Let's see what happens. Okay, I have a syntax error. Oh, I'm missing a comma. Look at that. And now as I hold up my left hand, it's on the left side of the canvas, the video is mirrored, which is incredibly useful for any kind of interactive application where you want people to see themselves reflected on a screen and interact with it. It's much more intuitive if that video is flipped horizontally. All right, so that's it. We have the video. Now is the time to incorporate ML5. All of the models, whether you want to look for key points on the full body, key points on a hand, or key points on the face, they all work the same way. The first step is to create a variable that will hold onto that particular machine learning model. And I'm going to call that variable FaceMesh because we're going to use the FaceMesh model. I'm going to navigate over to the FaceMesh page on the documentation. Let's run the quick start just to see what the example looks like. And you can see all of the points that it's tracking on the face. Now, you might be wondering, wait a second, where does this even come from? The models that are available in ML5 are not magic. There's not some magic system that knows how to find your face and put key points all over it. The FaceMesh model, and in fact, all of the pose detection models in ML5 come from the TensorFlow project. And you can find documentation around what are these models, who trained them, what data sets they were used to train on the TensorFlow website itself. And this is a really important question to ask. If you are working with a machine learning model, it's very helpful for you to think about who owns this model, who trained this model, and what data was used. That will really inform whatever decisions you want to make about how you want to use that model and in what context it's going to work well for. In particular, when you're tracking somebody's face, it's really important to be thoughtful about these kinds of questions. Back to the documentation. The next thing that I want to do is load the model itself. I'm going to add the preload function and say FaceMesh equals ML5 FaceMesh. And let's see what happens. So every function that you call in ML5 is namespaced under the variable name ML5. And in fact, in setup, if I say console log ML5.version, we'll see that version 1.0.1 is logged into the console. The next thing that I need to do is somehow connect this FaceMesh model with the video. The way that I do that is with a function called detect. And in fact, in this case, detect start. Start video. I've loaded the model and I've called the detect start function, which will trigger the model to continuously analyze the image from the video. Now, there is also a function called just detect that you can use if you want to analyze a single image one time only. But with detect start, what I need to do, and you can see this in the error message here, is I need to add a callback function. So the model returns the results of what it finds in the video asynchronously, meaning that after it's analyzed the image, when the data is ready, it will execute a function and pass the results into that function. So I'm going to make up a name of a function, call it got_faces. I'm going to define that function, and I need to give it an argument which will hold the data, the results of the machine learning model. And let's just see what's in there. Console log results. One object. So I'm just one person. I have one face. So that's why we're just seeing one object. But this model, presumably, if a second person, do you want to prove if this is true, Pat? Let's see if this is true. If you come here.
I think you need to
change the max faces.
Right.
This is important, but actually the FaceMesh model, I can also give it options. So I'm going to allow it to have a maximum of 5 faces now. Yes, now we have 2 faces. There we go. All right. Thank you for that demonstration. But it's actually going to be kind of convenient to work with it with just one face. So I'm going to put max faces back to 1 right now. Here's another aspect that's very important that I want to emphasize. Even though the model is being loaded from the cloud, when you call ML5 FaceMesh, the model, a file with a lot of numbers in it basically, is being downloaded from one of Google's or TensorFlow's servers. That model itself is actually executing in the browser. So the images that are being seen from the camera and being sent to the model are all happening on device inside your web browser. This is very important and quite different than if you were using another cloud-based service where you're actually sending your data, sending your images to another server to be processed through a model and then sent back. Everything is happening on device here. So the next step that I need to do is I want to be able to draw where those points on my face are on top of the canvas. So I have the model, I have the video, I have the results, but I don't have the results inside of the draw loop. So to do that, I'm going to create a global variable. I'm going to call it faces. I'm going to initialize it with an empty array. So when the sketch starts, it will assume it's detected no faces. And then I'm simply going to pass that array, those results into that faces variable. So now inside of the draw loop, I can access the global variable faces. But before I do that, let's actually go and add, I'm going to add the mouse pressed function. And in here, I'm going to console log the faces so we can just take a look at what's inside the actual object that holds all the result from the model. So let me make the console a bit bigger. And I think it's detecting my face. I'm going to click the mouse. And there we go. Now I can start to look inside of this object. So first of all, it's an array that holds one object, a face, and then all of these properties. You could look at the ML5 reference page, which will have all the documentation in terms of these properties of the results object, as well as a diagram that shows where all the points on the face are and what order in the array they are. But for now, one way we can just figure it out is by poking through this object in the console. You'll notice there's a key points object. That is an array with all 468 points. But one of the things that ML5 does is it takes that raw array of all the points and divides it into parts and gives you a bit more information. So let's focus on the lips for right now, because I think Pat's project is going to have to do it opening and closing your mouth. So if I unpack the lips object, I can see there's an X, a Y, a width, a height, center X, center Y, as well as an array of key points and only 42 key points. So let's first see if we can draw just the bounding box of your mouth. I have to remember I'm going into faces, index 0, dot lips, dot XY with height. And I can do that right here in draw. The first thing though is I should probably check to make sure that it's detected at least one face. I can use an if statement and say if faces.length is greater than 0, then let the face equal faces index 0. Let's just put it in a separate variable. And then let's draw a rectangle at face.x, face.y, face.width, face.height, stroke weight of 4, no fill, and let's give it a nice, I don't know, blue-ish, pinkish, I don't know, I'm gonna pick a random color out of a hat. And let's see what we get. Okay, I've made a mistake. Oh, I forgot dot lips. So there is no, it's interesting. Let's go back and look at the object. So I've made a mistake here. I went straight for assuming there is a box which has the full bounding box of the face, but I'm looking for the lips. So I forgot dot lips. So it might actually be nice for me to say let lips equals faces index 0 dot lips, since that's what I'm using here. And then I can change face to lips here. And these should be the properties. Okay, let's see if it works now. There we go. Uh-oh, what happened? So one of the unfortunate but beautiful things that's happening is that I mirrored the P5 video, which is only mirroring the way that it's displayed and not actually mirroring the data that's being passed to the ML5 library. But guess what? Remember how I was able to add a property called max faces to FaceMesh? And there's lots of other properties you could add, which are all on the reference page. I can also add the flipped property. And now look at that. And I don't know what I did. I thought I did no fill, but oh, I typed fill here. Okay, that was meant to be stroke. Okay, I wanted it to be see-through. There we go. So now you see that this bounding box is tracking my mouth. If I wanted to look at the specific points on the mouth, then I could actually dig into not just the X, Y, width, and height, but the key points array itself. So I'm gonna do a for of loop to look at every point. Well, I shouldn't use the variable name point because point is an actual P5 function. So let's call it lip point. That's a weird name, but I'll keep it. Let lip point of lips.keypoints. I think that's what it's called. And then I can just do a little, let's do a stroke weight of 2, and we'll make a green color to differentiate it. And I'm going to say, make a point. That's why of lip point.x and lip point.y. Okay, so I've got an error. Let's take a look. Lip.keypoints is not iterable. Let's go look again at that object to see maybe where I went wrong. Lips, oh, key points with a lowercase p. I capitalized the p, which is incorrect. If I had bothered to look at the reference, I wouldn't have had that issue. So let's lowercase this p. And I think now, there we go. So you can see, in addition to the bounding box, we are now have the contours of the actual lips itself that are being detected. And I could pick specific points to track. I could use those to draw other colors or shapes. I could give myself a really bright shade of lipstick or something. I'm sure you're watching this could come up with many more creative ideas. And obviously, in addition to simply just the lips part of the face, I could also use the left eye, eyebrow, right eye, as well as the face oval for all the other points. So that's the basic how-to load the model, open a video, pass the video to the model, get the results, and then analyze the results object and draw based on it. But what kinds of creative projects might you be able to make with that? Well, I'm going to turn it over to Pat to see what she can do.
What I'm going to do is I'm going to step away from the sketch that Dan just made and create another one to show you how to make the kinetic topography sketch, and then we'll combine it at the end. All right, so we're going to start by declaring a few variables. The first one is center, and center is going to be a vector, and a vector is an object that can hold 2 to 3 values, and I'm going to use it to hold the x and y values of my center coordinates. So center b equals to create vector, and this is a method within the vector class that allows us to create a vector, and I'm going to give it in the middle of the canvas. So let's do width divided by 2 and height divided by 2. All right, and then another variable that I want to create is going to be called pose for position, and I'm going to set it as a vector as well. And let's give it at, how about 300 by 300. So it's going to be at the bottom right corner of the sketch. Now inside draw, I'm going to draw the positions of the center and the position vectors using the ellipse function. And the ellipse function takes in a total of 4 arguments. The first 2 are going to be the x and y coordinates of the center of the circle. So let's do center.x, center.y, and this is how you can access the x and y coordinates of the vector. And then let's give it a size of 10 by 10. And I'm going to give it a color black. All right, so nothing's new here. We have a circle in the middle of the canvas. Let's do one more. Give it a color red and ellipse of pose.x, pose.y, 10 by 10. So now what I want to do next is that I want to move this red circle in the direction of where it is from this black circle here. So we have to do a few things. The first thing we need to do is that we need to figure out what is the direction between these two. So first, we're going to find the angle between the black dot and the red dot here. We're going to be using trigonometry. And I think Dan has many videos on this already, but essentially, we're going to find the distance between the x coordinates of these 2 points and the y coordinates of these 2 points. And then we're going to use the inverse tangent formula to find the angle between the two. So instead of just putting everything in sight draw, I'm going to create another function, and let's call it calc angle. And the parameters for these are going to be center and pose. So it's going to be the two vectors that we have right here, right? And then I'm going to now define x to be equals to center.x minus pose.x, and then y to be equals to center.y minus pose.y. And then angle will be equals to inverse tangent, which is a tan of y divided by x. Now we're going to return angle, and we're going to be doing this in the radians mode, but I'm going to change it to degrees first because it's more intuitive for me to understand. So we're going to change it by using the function angle mode, change it to degrees, and then inside draw, I'm going to call the function calc angle and put in the 2 points, center and pose, and then we're going to print out the result, which should be the angle. And as you can see here, what we have here is the angle 45, which is what we want, right? So where the x-axis here is 0, if you go clockwise, you get 45 degrees. It works when we're in quadrant 1. So I'm going to call this quadrant 1, 2, 3, and 4. Let's try a different point. So what if I put in 100, 300? So now it is in the second quadrant, but the return value is negative 45. But what we want is actually 180 minus 45, right? So we are going to be writing a few conditional statements. So let's start with the first one. So if pose.x is greater than or equals to center.x and pose.y is greater than or equals to center.y. This is in the case where it is in the first quadrant, then we'll just return angle. But else if pose.x is greater or equals to center.x and pose.y is less than or equals to center.y, which is the case that you are seeing right here, what we're going to return is actually, it's going to be what? 180 minus absolute value of angle. So if we do this and I click run, what did I do wrong? Oh, so it actually is less than or equals to center.x, and then this is more than or equals to center.y. Now we get 135 degrees, right? Now I need to do two more cases, which is when we're in the third quadrant, which is here. So let's do 100 by 100. Now it's going to be else if pose.x is less than or equals to center.x and pose.y is less than or equals to center.y. So if I just return angle, what we get would be 45, but what we want is 180 plus 45, right? And then for the last case, which would be 300, 100, yes. What we want is else if pose.x is greater or equals to center.x and pose.y is less than or equals to center.y, then return angle. And what we have here is negative 45, but what we want is actually 360 minus absolute value of angle. All right, so we get 315 degrees. And actually, we also want to do this as greater than but not equals to for the first case so that none of these conditional statements overlap. All right, and I'm going to actually delete the angle mode here because I want to be using radians right now. Okay, so now that we get the angle, now we want to get the direction between these 2 points, and we can actually use a method within the vector class called fromAngle. So we can do that easily, and I'm going to do it inside a function. So let's do function. How about calc dir for direction? Actually, let's do vel because it's going to be a velocity. So velocity is speed and direction at which this red circle is going to be traveling. And then we're going to need 2 parameters, the same one, center and post. And then how about I declare a variable called vel, and to call the p5 vector method from angle, all we need to do is put in p5.vector.fromAngle, and we want to put in the angle that is returned from the calc angle function, right? So how about I also create a variable called angle, and then let's call this function calc angle with 2 arguments, center and post. And then we just put an angle in here, and let's return, actually let's draw a line. We're going to draw a line between center.x, center.y, center.x plus vel.x, and center.y plus vel.y, right? I want to draw a line between these 2 points. And inside draw, I'm going to call calc vel. All right, let's delete this. We don't need this. So calc vel, and it will be center, comma, pose. There's no error, but we don't see anything right now. Why is that? Let's print what vel is. And as you can see here, it's an object with 3 values, x, y, and z, but we only have 2 values, x and y. And you can see that the values are less than 1. So the magnitude is very small. So what we want to do is we want to actually set a magnitude that is greater than what it is right now. So we can do vel.setMag, and this is also a method within a vector class. How about we set it to 100? Oh, I changed it to the radians mode, but I didn't change these values. So 180 will be pi, this will be pi, and then 360 will be 2 pi. All right, and now we have this line that almost there, but not yet, right? Not there yet. And that is because the distance between the black dot and the red dot is actually greater than 100. But how do we figure out what is that distance? We can do that easily using a function called dist, D-I-S-T, which allows us to find distance between 2 points. And we need to put in 4 arguments, the x and y coordinates of the 2 points. So center.x, center.y, and post.x and post.y. And then we want to put in distance in here. Okay, so now that we find the direction between these 2 points, now how do we move the red dots? So let's come inside the draw function. And now I'm going to actually set this function here to a variable called vel. And then instead of actually drawing the ellipse using the x and y coordinates of post.x and post.y, what I'm actually going to do is that I'm going to use a translate function. And I'm going to translate the origin point from the top left corner here to the point where the dot is. So let's do post.x and post.y. And then now inside the ellipse function, I can just do 0, 0. Click run. You should see the exact same thing, but the line is gone, and that is because vel was not defined earlier. All right, so now I want to move the red dot. I want to move it in oscillating motion. An oscillating motion is a back and forth motion between a center point, and that center point is going to be the point where it is right now, which is the position, post.x and post.y. And I want to move it back and forth, and I can use a sine or a cosine function. So the equation will be how I define this variable as oscillation, or OSC, and we're going to use, let's use a sine function. And then inside the sine function, I'm going to put in 2 pi times angle here. And then what we want is that inside here, we're going to translate it by vel.x, which is a vector, right, times OSC. And then vel.y times OSC. Let's click run. Angle is not defined. Okay, let's define angle. Let angle equals to 0. 18. Oh, I forgot to return. So inside here, we also need to return the vel vector, right? Okay, perfect. But it's not moving because we have not incremented the variable angle yet. So how about we increment it by 0.005. All right, so now, as you can see, it's oscillating around this point here, the original position where post.x and post.y was. So let's just try to change it to something else. Let's do 150 by 150. All right, so as you can see here also, the closer it is to the black dot here, the smaller the magnitude at which it is oscillating, or the amplitude, right? Perfect. Now, what I'm going to do is let's change from a circle to a letter. And I'm going to comment out this ellipse, and we're going to be using a function called text, which takes in 3 arguments. The first one is a string of text that we want to draw. I'm going to just draw a letter A, and then we're going to put in the x and y coordinates as 0, 0. Yay. Now, what I want to do is I want to align the text to be at the center for both x and y direction. All right, so now it's at the center. And we can also set the size of this string of text, and we can do it using the function text size. But actually what I'm going to do is I'm going to use a function called scale. And I'm going to, how about we scale it by, let's say 3. So that's really big. Let's do 2. Now that we have this code ready, why don't we put it inside a class before we make a bunch of them? So I'm going to come to this arrow here, click the plus sign, and then click create file. I'm going to call this file letter.js. And then before we start writing a class, make sure you go to index.html and integrate this file into the whole program. So all you need to do is copy and paste this line of code, change the name here to the name of your new file, in my case, letter.js, and now we're ready. All right, so inside the letter class, let's start with the word class. Let's call it letter, and then we're gonna write a constructor function. So what do we want to put in the constructor function? Let's start by going back here. I'm going to keep center as a global variable, and so is angle. So this angle is actually different from the angle in the calc angle here. Actually, I'm going to change the name here to theta so that we're not confused that they're different. So the angle variable that is global is the variable for moving the oscillating motion, right? And then now what we need to do is we want post here to be part of the constructor function. So this dot pose will be equal to create vector, and the parameter will be x, y. And then I'm going to write a method called display, and then we're going to put all of this here inside the display method. All right, and then don't forget this dot, right? So this dot, before I change all this dot here, let's put these 2 functions, calc angle and calc vel, inside the class as well. And when you put a method, the functions inside the class, you don't need the word function anymore, so we can delete that. And here also. And then now it's time to put in all of this dot. So center is a global variable, so we don't need that. We are calling the calcvel method inside the class, so we need this dot as well. We're going to put this dot OSC. Angle here is the global variable. This dot pose, this dot vel, this dot OSC. All right, a lot of this dot here. That's it for here. And then under here, we don't need this inside. put in this dot, and then this dot, this dot, this dot, this dot, this dot, here, here, and here. We don't need this inside the calc vel. We need this dot calc angle because we're calling the method. And then we don't need the parameter here. This will be this dot vel. I'm going to call this as this dot distance as well. And this dot pose, this dot vel, this dot vel. And we don't need the return function because it's already part of the this dot vel variable inside this class. I hope this is all good. Why don't we just start by creating just one object just to make sure that the class is working. So I'm going to call this variable L, and L is going to be a new letter object. And we need 2 arguments, which is the X and Y coordinates. And I'm going to put it as 150 by 150, just like what we have here. Then in here, we're going to call the display method. So L.display. Uh-oh, it seems like I forgot this dot for one of them. And I feel like Dan has a song. Okay, one more thing that I missed. 9. I don't think I need to set this dot vel to this. So we can just call this method here. All right, so now we have the same thing, but now inside a class. Now we're ready to make a bunch of letters inside a grid. So I'm going to start by creating an array called letters. And then we're going to create a few more variables, calls, rows, and size. And I'm going to set size to 20 actually. And then inside the setup function, first what I'm going to do is I'm going to calculate calls and rows here, which will be determined based on width divided by size, and rows will be height divided by size. And now we're going to store the objects inside a 2D array, letters, and I'm going to use a for loop, a nested for loop. So let I equals to 0, I less than calls, I plus plus. And then same thing for the j. So let j equals to 0, j less than rows, and j plus plus. Now to create a 2D array, inside the outer loop here, we're going to populate this letter array with a lot of empty arrays. And then inside here, it's going to be letters of I and j. It's going to be new letter object. But what I'm going to put here as the X and Y arguments, what we need is X will be equals to I times size, right? Because it's going to be spaced out by equidistance of size. And then let Y equals to J times size. And I'm going to put X and Y here. Now that we create letter objects, we just need to display them using the nested for loop. So I'm just going to copy this down here, delete this, and just call the display method. All right. Whoa, what's going on here? I forgot something important when you use any type of transformation functions, which are the 2 main functions, push and pop. So whenever you use transformation functions, you need to think about whether you want to save the transformation and then return back to the default mode before you call the next transformation functions, which is the case right now. So inside the display method here, we call translate and we call scale. To use the push and pop function, what you want is that you want to put it before the transformation functions. And so it is going to save the translate position here and then the scale. And then afterwards, we're going to put in pop. So it's going to return back to the original default settings, which is when the origin point is at the top left corner of the canvas before you call the next transformation functions. So if you do this, it should fix the issue. Wow, it's pretty cool. All right, I'm going to delete or comment out these lines. These lines, we don't need them right now. Okay. Right, so as you can see, all the letters are going from whatever the amplitude is down to the 0 point, right? But what if I want it to travel at a shorter distance? What I can do is actually, I can just multiply this magnitude here by a certain scale. Let's do, how about 0.3? So you can see that it moves a little bit at a short distance, basically. Instead of putting or hard coding this number, I'm going to actually set a variable, this dot SCL for scale, and put it here so we can just change it as we want. All right, and then let's go back to Sketch, and then I'm going to put in 0.3 in the constructor function here. Now, what I want to do is I'm going to comment out this angle. And as you can see, it's not in the center. Actually, I need to fix this a little bit. So instead of just I times size and j times size, I want to also add by size divided by 2 for both of them. Perfect. Next, we are going to actually now draw a rectangle. I just want to draw a grid so that you can see. So I times size, j times size, and then size. Wow, okay. We also want no fill. All right, and how about we scale down the letter to just 1.2 maybe here. So let's do 1.2. So it's smaller. I want to get that feeling of like a wave. And we can do that by actually add a little bit to the simple harmonic motion equation. So we can add some shifting angle here. So let's call it this dot shift. And actually, let's just try it. If I shift it by, because this is in radians mode, so if I shift it by 0.4, you can see that everything is shifted a little bit. So what I want to do is that I want to shift it based on its distance from the center point. So I'm going to define this as this dot shift, and this dot shift will be mapped based on the distance, right? And between the value, how about I just do 0 to 1000? And I know for this particular sketch, the canvas size is 400 by 400. So actually the distance is not up to 1000, but that's okay. You can change or play around with these values to get the look that you want later. But I'm going to map it to the values 10, 0. Let's see what happens. It looks a little bit wavy here. I don't know if you can tell, but why don't we first move it and just see what happens. Ta-da! That looks really cool. And I can actually stop here, but I'm not going to. I'm going to make it a little bit more interesting. And what we can do is, how about we also change the size of the letter A here? And we can do in a very similar way by using the oscillating motion. So we're going to actually create another variable. Let's call it this dot, how about font s, right? And we're going to set it to be equals to, I want it to also oscillating back and forth. So this dot font s is going to be mapped to this oscillating motion, which is this dot OSC, which will go between -1 and 1, right? Because the magnitude is just 1. And I want to map it to the values of, how about 0.5? Actually, let's do 0, 1.5. And you can play around with these values as well. And we need to make sure that we put this dot font s in here. Let's see. Wow, okay. So because I put in 0, you can see that there's a point at which the letters just go away. So you can actually, if you don't want that, you can do, let's say, 0.3 maybe. And actually another interesting thing that I want to show is, what if we do this dot font s and set it equals to this dot OSC, which oscillates between -1 and 1. Do you see that? The letter actually flipped, which is an interesting look. So play around and see what you like. I'm going to keep it as this. And then now what I want to do is, because we're going to be putting it back with the video part, right? I'm going to set the canvas size to 640 by 480. And then I'm going to set the background to black. And also we don't need the rectangle anymore. And then how about we set the color of the ellipse in the middle or the center as the color white. And then we're going to set the font to white. All right. So the next thing, what we can do is also, what if we move the center based on where the mouse is? So inside draw, all we need to do is actually just set center.x to be equals to mouse x and center.y to be equals to mouse y. And there you go. And remember the variable scale that controls how much each of the letters travel. I'm going to play around with that variable as well inside here. So how about I write a conditional statement that says if mouse is pressed. And mouse is pressed is a Boolean variable that returns true when the mouse is pressed and returns false when it is not. We're going to change letters of I and j dot scl, the scale, right, to 1 when the mouse is pressed, or else then we're going to set it to 0.3. All right, and I have a typo here, and then here. Let's try that. So the mouse is not pressed, the mouse is pressed. All right, the mouse is not pressed, the mouse is pressed. One last thing that I want to do, just to add a little bit more complexity to this. So instead of just setting it right back to 0.3, when you release the mouse, I'm going to write another conditional statement that says, if letters of I and j dot scl is more than 0.3, then I want to slowly reduce it by 0.01. Then else here, we're going to set it to this. Just to give it a little bit of a nicer transition. I don't know if you can really notice, but all right. Anyway, this part is all good. Now we're going to put everything back together. All right, so when you were not looking, I have already put Dan's code with mine. I didn't change anything at all. We just combined the two together. And as you can see, this is not the effect that we're looking for. So let's just edit this a little bit. So first, I'm going to hide the video. Actually, we don't need it at all, right? And then what we want is that the face is already detected. I want to actually, instead of just using the lips, I'm going to get all the key points for the whole entire face. So let's define a few more variables. So I'm going to actually comment out Dan's code here, and I'm going to define a variable called face, and let's set it equals to faces with index 0 because we're only detecting one face. Then I'm going to set another variable called key points, and it's going to be just face, which is faces of 0 dot key points. And then we're going to loop through the entire thing. So I is equal to 0 to I less than key points dot length I plus plus, and I want to draw all the points out. So we're going to use an ellipse function, put in the x and y coordinates of all the points. So key points of I dot x and key points of I dot y, and let's set the size to be 2. And then let's fill it with the color white. Let's try that. Can you see that? You see my face in the back there? Because the circle is kind of small, it's a little bit hard to see, but you can see that there are so many points on my face. So next, instead of using lips, what I'm going to use is that I'm actually going to pull out a specific point on the mouth here. And I actually happen to know what are those values. So let mouth top equals to key points with the index of 13. And let mouth bottom to be equals to key points of index 14. And then let's just draw these points out. So mouth top dot x, mouth top dot y. Let's do 10 by 10. Same thing for the bottom. All right, and then let's color it white. Oops, key points. You see the points on my lips, on my mouth? Perfect. Now, what I want actually is the center point between these 2 points, and I'm going to define some variables up here. I want to define mouth X, mouth Y, and mouth W for the width. And down here, what I'm going to do is I'm going to calculate mouth X to be equals to mouth top.x plus mouth bottom.x divided by 2. And same logic for mouth Y. And then let's just draw out a circle for this point. Mouth X, mouth Y, 10 by 10. And we can put this back as well. And you can see there's the middle point there. And why am I doing this? I want to actually control this instead of with the mouse location, but with our mouth location. All right, so now what we're gonna do is I'm going to comment out these two again. And then instead of setting center.x to be this, it's going to be mouth X and mouth Y. All right, so you can see that it's tracking the face. But if I open the mouth, it doesn't do anything yet, right? But let's make it do something. So how about we set mouth W to be equals to, the calculation would be mouth bottom dot Y minus mouth bottom dot X. And I'm going to print this out so you can see the value. So mouth W, oh, it's negative because it should be top minus bottom. Whoa, I did this wrong. It's mouth bottom dot Y minus mouth top dot Y. All right. See, as I open my mouth, the value increases. So we can just set a threshold at which we want to call this, right? So how about when I open my mouth, it goes up to like 40, 50 here. So we can just do, what if we just do 40? And where are we gonna put it? We're gonna put it in this conditional statement. Instead of mouse is pressed, we're gonna do if mouth of W is greater than 45 maybe. Let's run. And there you go. So we're gonna bring Dan back so that he can play around with this sketch.
Whoa. Oh, I love how you're drawing all the points of the face, like very subtly there. And then that's the center point.
Right.
Ah, okay. My mouth didn't open as wide.
Let's just decrease this. Let's do 30. Yeah.
That is really fun. I wanted to check how, one thing I was curious about, I'm just looking at your code here. So, I see. So you pick specific points and then you found the top and the bottom and then averaged them. So it's interesting. I'd be curious to see if we use the lips object, which analyzes the lips and in theory finds the center, if that's the same point or a different point. But it's good to see this technique. It'd be interesting to think about what other kinds of text you could put in here. It's all the letter A, but you could imagine this being like a poem, or it somehow is changing as you're interacting with it. It's also maybe something to consider is adding the lerp function, because sometimes the points that come from the model, it's actually quite smooth, but it's a little bit jittery. And the lerp function is something that anybody who's watching could try to add for some smoothing. Amazing. Thanks everybody for watching. Thank you, Pat, so much for demonstrating this project. Hopefully you've gotten both now a nice introduction to the new ml5.js library, and I hope you try that out, as well as seeing how you could take a creative computational design, which there are many, many to choose from all of Pat's videos that I encourage you to go and check out, and see how you might combine them with interactivity from the FaceMesh model, but you could also try hand pose or body pose. And this video will be included on the Coding Train website with a passenger showcase page. So if you make something based on this video, please share it. Don't forget to check out Pat's channel and subscribe, and I'll see you next time on the Coding Train.